I appreciate you stopping by to check out yet another episode of Vintage Audio Review. In this episode, I'm going to talk about the SCHIT, that's SCHIIT, Aegir Power Amplifier. Aegir is how I'm pronouncing it. It's spelled AEGIR. It sold in 2019 for about $800, and its specifications were 20 watts per channel into 8 ohms, both channels driven at not more than 0.01% THD from 20 hertz to 20 kilohertz. Double that power into 4 ohm loads, 40 watts per channel, and running as a mono block, it could put out 80 watts per channel. The frequency response was listed as -1 dB from 20 hertz to 20 kilohertz. We'll see how it does against those specifications in a little bit, but we'll do a little tour. I mean, there's not much around front. There's a little bit more around back. I'll pop the cover off and we'll see what's going on inside. And then, of course, there will be data and finally my comments. Now, I don't want to let the cat out of the bag, but please make sure you listen to the comment section of the video towards the end, as this had something. Anyway, just watch the end of the video, and all of the video, I hope. So let's go on with the tour. Here is a view of the front of the Aegir Power Amplifier. This is our on-off switch. There's an LED light here, and that is the standby alert light. And then we have another LED over here, and that is the operate light. This is the rear of the SCHIT Aegir amplifier. You can see we have nice three-way binding post type of connectors for the speakers. There is an on-off switch, your power cord receptacle, and then there's a fuse inside here. You have unbalanced gold-plated inputs for right and left channels. However, there is just a single balanced input. This is a side view of the Aegir Power Amplifier, just to show you how there are heat sinks along both sides of the Aegir. This is a view of the Aegir amplifier with the top cover removed. You can see a nice size power transformer here, and then we have our power supply capacitors, bridge diodes, and just the assorted electronics that make up the Aegir Power Amplifier. This is a closer view of the circuitry, kind of just showing how things were built and put together. Here is our standard THD SNR plot at 1 kilohertz with the Aegir putting out 5 watts into 8 ohms. The channels are really well balanced, and you can see that in order to get the 5 watts, we're putting in about 668 millivolts. THD is really low, 0.001% we'll call it. SNRs are looking really good, about 98 dB. THD plus noise also looks really good at around, we'll say minus 94 dB. The only thing I don't like is it's only got about 20 dB of gain. That is what it is. And in case you were wondering what the harmonics look like, the odd harmonics are less than the even harmonics, which isn't what you would expect for solid state, but it is the case with this solid state amplifier. I believe they're saying it's class A, and this is for the case with it putting out 5 watts into 8 ohm loads. Switching over to 4 ohm loads, here's our THD SNR plot at 1 kilohertz, and we're putting out about 5 watts into those 4 ohm loads. If you compare this with the 8 ohm load case and 5 watts, the SNRs are down about 3 dB for the 4 ohm load case, which is pretty much what you see. The THD is better with the 8 ohm load case. The gains didn't really change, about 19.5 dB. I should point out that I am using the unbalanced RCA inputs. And if you're curious what the harmonics look like, here they are. You can see they're still pretty much about the same. We do have our even or second harmonics higher than the third or odd harmonics. Here is the frequency response of the Aegir with it putting out about 5 watts into 8 ohm loads. Now we're starting at 10 hertz and we're going out to 40 kilohertz, and we're only down, what, a half a dB at 40 kilohertz. If you look at 20 kilohertz, we're down a little over a tenth of a dB, and at 10 hertz we're down, what, 0.05 dB, and at 20 hertz we're down even less than that. So this thing has an outstanding frequency response, and those channels are balanced really, really well. With the Aegir putting out about 5 watts into 4 ohm loads, you can see that its frequency response is a bit worse than it was with the 8 ohm loads. At least over here at 40 kilohertz, we're down a bit more. I think we were down half a dB in the 8 ohm load case, and now we're down, what, 6/7 tenths of a dB. At the low end of the band, it looks to be about the same at 10 hertz. And overall, it's really, really flat between 20 hertz to 20 kilohertz. There's maybe just a little bit more loss here at 20 kilohertz. I mean, we're talking 0.2 of a dB versus 0.15 dB here at 20 kilohertz. For the 8 ohm case, it was about 0.15 dB, and here we're about 0.2 dB. So not really that big of a deal. Here we have the Aegir putting out its spec rating of 20 watts into 8 ohm loads. And with the A weighting applied, the SNR is supposed to be better than 114 dB, and we're well missing that mark. The distortion looks pretty good, 0.06% we'll call it, and the specification is that it should be better than 0.01%. You can see once again the gain is right around 19.6 dB. DHD plus noise got quite a bit worse at minus 65 dB, we'll call it. Here we have the Aegir putting out its rated maximum power into 4 ohm loads of 40 watts. The THD is supposed to be better than 0.01%, and we're about an order of magnitude worse. We'll call it 0.15%, which is still pretty darn good. The SNRs also got worse, about 8 to 10 dB. And the gain stayed about the same, which kind of you would expect. And this, of course, is with the unbalanced RCA inputs being used. And I do have the A weighting applied to try to improve the SNR, which is supposed to be 114 dB at max power, so it's nowhere near that. And it's not as good as it was in the 8 ohm load case. In case you were wondering what the Aegir's multi-tone response looks like, with a minus 12 dBV signal going in, it's showing a distortion-free range of between about 12 to 16 bits. And in case you're wondering what the IMD response looks like for a 19 and 20 kilohertz tones, you can see that it looks pretty good. Here's our tones here. We have our sidebands here and here, and then we have the 1 kilohertz difference sideband here. And that the 1 kilohertz one is the worst case, and that's about minus 90, which would translate to about 15 bits of distortion-free range. Right now, I've got the Aegir acting as a monoblock, which means that I've got a signal going into the one balanced input. There's only one on this guy. And then I have the speaker or the load connected between the two plus terminals, and one is actually labeled like a big plus and a little minus if you wanted to use it as a monoblock. And the specification is that it should be able to put out 80 watts into 8 ohms. They don't really say what the THD is, but overall this is what it's looking like. You can see our gain is about 6 dB higher from what it was as a stereo amp, 26 dB of gain almost. SNR, what, about 79 dB. THD, not too bad, 0.14% we'll call it. And the THD plus noise minus, we'll say 58 dB. And you can kind of see all the stuff going on here. And overall, that's the performance out of this Aegir amplifier. Here is the Aegir's monoblock frequency response from 10 hertz to 40 kilohertz. And it's looking pretty much like it did as a stereo amplifier into 8 ohm loads. At 40 kilohertz, we're only down, what, 0.6 of a dB. And it's pretty flat, 10 hertz down 0.05 dB. So it has an outstanding frequency response, whether it's used as a monoblock or as a normal stereo amplifier. Here we have the Aegir's crosstalk from 20 hertz to 20 kilohertz. There is no specification, but it looks really good anywhere from, we'll say 12 dB and down to maybe 78 dB, which is really good for the crosstalks I have measured. And this is with the active channel putting out 5 watts into 8 ohm loads. Right now I'm putting a 1 kilohertz square wave into the Aegir power amplifier, and the outputs are connected to 8 ohm loads. This purple trace here is actually the output waveform, and it's showing a rise time of about 1.83 microseconds, which actually is fairly fast. However, it is a fairly small output signal. It's like 1.5 volts into the 8 ohm load. And you can see that my input signal does have this ripple on it. It had a little issue with it, but it's since been fixed. And there was no specification for the rise time. It kind of just gives you an idea. Here is the phase difference between a signal going into the Aegir and coming out of the Aegir at 1 kilohertz. And basically there is no difference in phase at 1 kilohertz. If we go down in frequency to 100 hertz, there is a difference in phase between the input and output, and that would be about, I don't know, 3 degrees, maybe 4 degrees of phase difference between the input and output signal. Here is a plot that shows the Aegir's output impedance / damping factor. And the damping factor is the one that most people look at, and that would be this line here. And it's about 240, 245, which is very, very high. What's interesting too is the output impedance is actually negative here, and the reason for that has to do with the way that the amplifier acts with an open circuit and a load, and that probably is relating to why it has such a good damping factor. I should point out that the Aegir weighs in at about 20 pounds, and it is a Class A amplifier. As you saw from the test data, it did a really good job of meeting its specifications, except when you got to the higher power levels like 20 watts into 8 ohms or 4 ohms. Its THD wasn't bad, but it was nowhere near the 0.01%. At 5 watts into 8 ohms, it met the THD requirement. Its frequency response from 20 hertz to 20 hertz was within the requirement of minus 0.1 dB. So I thought it did really good there. It had an outstanding damping factor, one of the higher ones that I've measured. And so that all looked really good. I was kind of happy with its performance, even the THD not being anywhere near 0.01%. I think it was 0.1 or 0.2. I mean, it's still just not really that big of a deal. I was looking forward to listening to it, and one of the last tests I do is the rise time phase test, and I only have a few points of data for that. And the reason why is that when I did the 10 kilohertz sine wave going in and then measuring at the phase difference at the output with it, running into an 8 ohm load or 8 ohm loads, and I just look at the one channel, but both channels are being driven. The waveform started getting really weird and then went away, and I looked over and I saw a puff of smoke coming out of the Aegir. Now, I'm not sure exactly what video number this will be. I'm currently at about 153, 54 videos. I have not had anything smoke. Now, I don't do 100% amplifier testing, as you know. I do phono stages and preamps, and but I do a lot of receivers and amplifiers, and I have not had anything ever smoke. I've had them blow fuses every now and then. Sometimes they just can't handle being pushed to their max and they'll blow a fuse. That's okay, but no harm's done. And I mentioned that in the videos. I've had other ones get hot and kick in the thermal protection and shut down. Still no harm. So this guy just started smoke, a puff of smoke. I unplugged it. I waited a half hour, plugged it in, and it has the little lights. They would flash on that it's ready, and then the other light on the right would be solid, ready to go. You'd hear the relays click on, and then you'd see a puff of smoke come out again. So I did reach out to SCHIT, and unfortunately it's not under warranty, so I would have to send it in now. As I mentioned, this belongs to a buddy of mine, and he was kind of happy that it died on my watch rather than him using it. I mean, I was putting in a 10 kilohertz 1 volt RMS signal, maybe a tad over 1 volt, and just for grins I tried that same test with a couple pieces of gear, the Carver M400A Cube. No problem with 10 kilohertz 1 volt. I tried an Ayama A07 amplifier, no problem with 10 kilohertz, didn't care. And then I tried a Crown D75 amplifier, and it didn't care that it was 10 kilohertz with that level of signal. So with all the microprocessor controlled, the new guy, it didn't like that. So go figure. I don't know, some of these other companies figured out how to protect against that, but I probably will send it in. It's beyond what I would want to repair with all the stuff that's going on in surface mount, and it's really not that important to my friend to get it fixed, but it may be interesting to find out. But they weren't offering to, hey, we'll fix it for you. I told them about the channel and that kind of thing, but anyway, I'm not sure if it'll get sent in. But that's kind of my story on it. I'm kind of disappointed that this new thing with the microprocessor in there monitoring the output voltage and amount of current and that stuff, that it wasn't smart enough to realize it was having some difficulty with a 10 kilohertz 1 volt RMS sine wave going in. Anyway, I'll get off that now. So, other than that, I never got to listen to it, so I can't tell you what it sounds like. That's kind of my take on it. I probably wouldn't recommend this guy just because of it's not able to handle something that a 40 some odd year old Carver Cube can handle. I mean, anyway, but so that's kind of my take on the the Schiit Ager. It did perform well as far as on the bench, but only to a certain point. I thought I would provide an update or epilogue, as you might want to call it, on the Schiit Ager power amplifier, and I ended up sending it into Schiit for repair. I thought they did a pretty good job with the process, and they only charged me $60 for the actual repair, which I felt was quite reasonable. And then, of course, you add about 40 bucks shipping to and from. So it adds up, but it was not all that bad, all things considered. So what did they find? I'm going to pull up a zoomed in picture, and if you look real closely, you can see that one of the bridge rectifiers has a crack in it. Now, I did not notice that. I did not sniff around to see if maybe something was burned real obvious, but it just wasn't real obvious to me. Had I seen it, I may have attempted to do the repair myself. I'm not sure how much difficulty it would have been to get at the bottom side of the circuit board, but overall I'm satisfied with the repair process. Now, they took probably about 2.5 weeks with the shipping when they got the unit to getting it back to me, so that's really not too bad. So how many bridge rectifiers have I had blow up on me and all the things I've tested? 0. Well, okay, 1. So you can take that for what it's worth. I mean, they do short out in gear. Usually it's from a power surge, from what I've seen on the line. It can usually take out a bridge rectifier where they're all in one units, or whether they're a packaged bridge rectifier like one of these, or whether they're just individual diodes. Now, I think there was a episode where I did have a bad bridge rectifier, and it came in that way. It wasn't something that happened when I applied a 1 volt 10 kilohertz signal to it, like this guy. So anyway, I'm thinking it was more of a latent problem with that bridge rectifier, but anyway, it is what it is. So once I had it back here, I decided it was only fair to give it a listen to, so I connected it to the Wilson WA3 Puppy 2 loudspeakers, and I used my SAE preamp equalizer, which there will be a video on, or maybe by the time this video comes out I'll have done that video. And I hooked it up to my DAP and listened to music for quite a bit, and it sounds really good. I mean, it's only a 20 watt into 8 ohm load kind of power amp, but it had nothing lacking as far as the sonic qualities of it. And I got it up to 96 dB SPL peaks every now and then, and that was with a little over 20 watts maybe, and it didn't really seem too stressed. However, there was a point when I was playing it pretty loud that I thought I heard it starting to stress out a little bit, but with the 96 dB SPL peaks that I was hitting, brief moments, but and then be back to 90 dB. Oh, that's pretty loud, so it blacks nothing in the sound. Like I said, I'm not sure what happened with that bridge rectifier, but that's just one of those things. So I thought I would just give the rest of the story, so to speak. So with the right speaker, a decently efficient speaker, I think this amplifier would work really well. So once again, I look forward to hearing your comments, and if you like the video, of course, thumbs up. And a big one is if you haven't subscribed, please subscribe. That's the only thing I ever ask, so the channel will grow. So until next time, have a great day or night.